flow path. A few words about what I'll be talking about. These are questions that arise when DPI solutions are developed and implemented. So the topic of the presentation is to form a checklist for the DPI equipment before it's implemented and implanted in the transport network. This information is based on the experience. For 8 years, I've been dealing with, as a member of the team, with constructing global NECAS networks. Our main task is to protect from the DDoS attacks on DDoS mitigation. The global network that we represent is the multiple nodes of presence, point of presence globally, where every point of presence is a certain hardware that can be bought. It doesn't have any custom elements. The only custom element there is software. So the DPI software developed by us. So this process has been going on for 8 years. 8 years of design, starting from the selection of the equipment to the installation of the software. So design, research, and installation. The main aim of the solution is to be available and available for traffic analysis, for monitoring and provisioning, as well as DDoS mitigation. What is DDoS mitigation solution? Now, it's analysis, going back to the deep-packet inspection. It's analysis of the traffic and the networks at all the levels, from the primitive analysis based on the IP addresses ports. So, following sessions, traffics, connections, and behavior analysis of each user using the big data instruments. Consequently, many of you have heard about the term L7 packet filtering. It is where it is discussed very often, and it has some hypothesis in it, assumption inside the architecture. An assumption, which sounds as follows: simple packet-based analysis is just enough to tell malicious intent from a legitimate one. L3, L7 wise. This assumption appeared because it's very useful for and convenient. If you want to remake a session, TCP session from the packet, you need to allocate a lot of the RAM. It's difficult to find every connection, and it needs to be done for every packet. Then system engineers don't like the security solutions that are introduced or implanted into the networks when all the traffic is passed through this solution, because the engineers know very well that these solutions are undependable. The main task of a system administrator and system engineer to keep the uninterrupted accessibility of information. And these solutions then negatively affect the service. So very often the DPI works based with a copy of the traffic and some mirror port. Would be great if limited by net flow
Это очень
IPX.
удобный подход для построения. Проблема в
It's a
том,
very
что
good approach,
уровневая
and
система
convenient
CCTV
approach. But the only
у
problem
нас
here is
не
that
просто так. То есть это
TCP/IP layering is there for a reason.
не чья-то прихоть.
It's not somebody's whim.
Уровневая система, структура сети
The
принципиально
layering of the
важна для
network is
функционирования. Сеть
principal
работает именно на уровне. Пакет — это единица
for
данных
its
третьего уровня.
functioning, and the
Протокола
packet
IP.
is the
Уже
third
на
level
уровне протокола TCP у нас
unit.
нет понятия
At the
пакет. Есть понятие сегмент. Это
STCP/IP,
разные
we
вещи.
already have a
Каждый, кто
segment, not a
сталкивался
packet.
с MSS клэмпинг, это знает.
Those who
На самом
came
деле на
across
уровне TCP у нас есть
clamping, they know about this. At the TCP level, we have
выше,
sessions.
соответственно, есть DLSS, еще
Then
выше
comes
уже имеется просто поток
TLSS,
данных.
and then for data, the seventh level. Thus, ignoring the layering of the network makes the solution vulnerable, and it was more vulnerable at the times when everything was sent in the internet by a clear text. 3 months ago, in the GitHub, there was a repository called Goodbye DPI. It included repository that used a number of primitive, but very smart and simple techniques, like an analysis of the identification field, TCP fragmentation, and certain HTTP header handling, like casing, and so on.
Которая оказалась, ее оказалось достаточно, причем даже не всех этих техник, а одной или двух комбинированных.
And those things, 2 or 3 things combined, will be enough to bypass all the DPI solutions already implemented in networks.
Когда мы говорим про что-то, что передается в clear text, как в заголовке, в протоколе TCP, но у нас в 2017
And this is when we talk,
есть протокол TCP.
when we use HTTP as protocol. According to statistics launched at the end of 2015, the Let's Encrypt provider published issued more than 60,000 millions of certificates. And now, based on the Mozilla Foundation statistics, and according to the Firefox telemetry, more than 60% or 2/3 of the website are visited on the HTTPS. Thus, the L7 packet filtering was vulnerable even at the clear text level. At the current level, with the TLS being so widespread now, with the mechanism similar to PFS, the traffic analysis per packet is useless even for the purposes that we're doing, and for our purposes, for DDoS mitigation. What is PFS? Perfect forward secrecy is a concept realized in the ephemeral Diffie-Hellman ciphers. It already works now. It worked in the SSL. It worked in the TLS, and it's mandatory in the TLS 1.3, ready for release. The idea of the PFS is that this connection is impossible to decrypt. Even if you have a private key, it's impossible to do. If you're looking at the copy of the traffic, client and server, they have keys, and it's impossible. It makes impossible for a situation when we recorded traffic for a certain period, 3 months or 3 years. We want to decipher what was there. Thanks to the perfect forward secrecy, it's impossible. On the way, the perfect forward secrecy breaks a number of DPI solutions used for many security purposes, including the enterprise security. 70% of HTTPS requests come and go without analysis. They use the PFS.
70% HTTPS запросов проходит без анализа. Причем это не просто 70%.
This is not just 70% of the request. What is important there is 60% of the legitimate users use the PFS. And 90% of malicious, of bots, they use it because the perpetrators know very well that if the PFS encryption, they have a big chance of bypassing the DPI solutions. What are the purposes of DPI that exist now? I told you about the DDoS mitigation, told you enough. What are other purposes? It is overall the quality of the service, prioritization of this or that kind of traffic based on the parameters, based on the flow inspection. It's also a parental control, consensus limitation. Then targeted advertisement. Copyright abuse of countermeasures. It's a blocking of the content, that is. And then the lawful interception. All these needs to be done in the transport network. And we need to consider here that currently the needed analysis at the level of the session. What does it give us? It gives us the situation when the DPI solution needs to consider the difficulty, computational difficulty. And simple example here. Many DPI solutions offer the functionality of catastrophic backtracking. And there are a number of problems here. You can see it on the slide with the link. Sometimes we have a very difficult case of comparison. And the whole range of DPI solutions that use this approach, they don't give any warning for this. And here we face the following dilemma. Either we need to spend a lot of up to a second of the machine time to compare those streams, and the traffic speed falls dramatically, or we need to stop the packet analysis and pass it through, depending on our tasks. What does it lead us to? The DPI is commonly believed to be a silver bullet. It sounds very nice. Packet inspection. It's like a fridge. You buy it and it solves your problems. You maybe need to adjust it a little bit, but it's capable of solving our problems of keeping food. But it's not. Reality is not the case. For now, DPI is just not a line of products. It's not a characteristic of a broad range of solutions. It's just a common characteristics of solutions that solve various problems, each designed to handle a single DPI goal. The more tasks you set to it, the worse it deals with it. A single piece of equipment won't cope with every DPI goal. Moreover, if it's aimed for solving only one task, there's also a trade-off, a compromise between the packet processing speed and the expected functionality to a certain extent. We either enforce the functionality and the speed suffers here, or we prioritize speed and the functionality suffers. Another problem of the DPI solution is that the network design, the transit network is supposed to be transparent for applications. Applications depend and count on this transparency. It's a transfer of voice and voice IP and the gaming protocols, overlay networks, enterprise VPN, modern web also counts on the network design that is described in the RFC. There's no deep analysis of the non-standard traffic. HTTP, MPTCP, QUIC, they are all count on the regular network design. More than that, they introduce TLS 1.3 DNSSEC and CAA, hoping that the transit network is transparent. DPI breaks this transparency, and this ends up in has its own consequences. A number of applications suffer from these problems. For example, this is a slide from Eric Riscola, when the TLS 1.3 was introduced. Serious problems appeared. 1 to 10% of the range was lost because of some middle boxes that could not handle it, did not support it. Thus, TLS suffers from the non-transparency of the network, which has its negative impact on the users. How will the adaptation to this happen? At the roundtable on security that took place in St. Petersburg, we learned that introduction of the renewed and of the updates of the firmware last 4 to 6 months. What is this time used for? For vendor needs 2 to 3 months to write this fix. It's impossible to fasten this process. For the next 2 to 3 months, in total it's 6 months, the rollout of the update happens all across the IP network, because the main task of the operator to keep the non-stop activity in the network. Then we have 4 to 6 months. In case we have a DPI solution, we need to adapt. It needs to adapt to the evolution of the network to the 7th level. Modern application, gaming, voice IP, application IoT, and malware, of course. They used modern approaches to continuous integration, continuous deployment that allowed to update the release several times a day. What does it lead to? In case we have a DPI solution, the non-support of a certain type of traffic or malware will not be seen as a vulnerability, it will be seen as a new functionality. We can ask for an update of the equipment and firmware, and resources that trying to bypass this DPI. What is this? They can update the program twice a day. So it's an arm race that the vendors will lose. And what does it end with? The DPI solution that reviews every packet is insufficient. It works very well for if you're fine with the Pareto principle of 80-20. If you're happy with spending 20% of your effort to solving 80% of your task, this is your solution. It's once again the parental control, quality of service, the advertisement, and certain traffic blocking based on the pattern mentioned by Alexei, with a full understanding that the users who want to bypass it will do this. If you have a task of blocking 100% of a certain content, a situation where we don't have control over the client or server in the client-server relationship, they can play their own game, they can pretend that establish a connection and forget about this connection. The memory is allocated for this, but with the big use of such clients, DPI solution may just stop functioning. And if it's put in the middle of the networks, the whole network will stop functioning. As to the security considerations, another thing you need to consider when introducing DPI solution. DPI solution is complicated. It's very difficult to approaches to security are different with all the vendors. I don't know how very often they update their DPI solutions. What we can say for sure is that in the world there are solutions like Finfisher, which have in the datasheet words that say that it is used for installation without to analyze traffic. But people who work with such things, from perpetrators to companies, they know very well that the operator's network can have complicated devices. In case this is just certain surveillance, maybe it's not a problem for the operator, but if it's a perpetrator who will get access to DPI and control of the DPI solution, it's difficult to imagine the consequences, the bad consequences. You know, they can do anything they want. What does it lead us to? The transparency issue and the security, network security issue here is a major one, the principal one. If there is a certain network community, network structure, if they want to import some non-transparent solutions to the IP network, they may task for this, to standardize this solution, to join the activities, communities and committees that are involved in standardization, so that all participants of the networks, members of networks, would understand what is happening, like RIBE, ETF and ICANN, other communities that are involved in considering all the demands of the stakeholders. So the desires and the requirements need to be considered if we want to be serious. Either this or we have an unreliable IP transport. Ad hoc applications that bypass unreliable IP transport and inherent instability of the core infrastructure.
Но вопросы будут в конце панели. Спасибо.
Thank you, Artyom. If you have questions.